this session. Okay. Uh, Guys, in the previous class, we have discussed about the data transformation. Okay. And I'm going to recap that one and I'm going to continue the session, guys. Okay. Previously, okay, in the second unit, that is pre-processing, we have completed data cleaning part. After that, data integration we have completed, and the next one is data reduction we have completed. Okay, the last and the final one is data transformation and discretization. Okay, we are in the last topic of the uh, second unit, guys. This is a simple one, guys. Okay, you can easily understand and somewhat interesting also. Okay, and easily score the good marks also in the second unit if you concentrate it. First and second unit, you just okay, you have to concentrate, guys. You will get the direct questions in these units. Okay, and moreover the topics also very less, guys. First 2 units you have to concentrate. Okay, don't leave these shop okay, these units, guys, okay, for getting the good marks in the exam. Okay. Okay, totally you will get that is 14 plus 2, 16 plus 16, 32 marks. You can score these in these units, guys. And the simple one also. These two ones also very simple and less content also there, guys. Particularly second unit, very less content. Only 5 topics will be there. Okay, introduction part. The next one is uh, cleaning, integration, reduction, transformation, and discretization. Okay, we are in the last topic, that is data transformation. Okay, what is the importance of the data transformation, guys? Okay, till now we have cleaned the information, we have integrated the data from the multiple sources, we have reduced the content also. Okay, what is the importance of the data transformation? Okay, after these three things, we are going to input this data to the data transformation. Okay, what we are going to do in this data transformation, guys? Normally, guys, data mining algorithms need particular type of format. They need the appropriate form for the data mining. That is why we have to convert our format to the format that is required for the data mining algorithm. Finally, we have to give the any data to data mining algorithm, right? We already know that one. Okay. Okay, in the data mining algorithms, they need some appropriate format. Okay, in that format only we have to give the data for the data mining algorithm. That is why the data transformation comes into picture, guys. What it will do is it will convert the data from that is okay one format to the format that is needed for the data mining algorithms. That is the importance of the data mining transformation, guys. Okay, understand, guys, right? Let us see different data transformation techniques, guys. Okay, here there are different strategies are there for the data transformation. Smoothing we have already seen, guys. We have seen binning and regression and clustering. All these things already we have seen in the data cleaning part. Okay, the same things also we have to remove. Okay, we will use here. Okay, what we are going to do in this data smoothing is that we are going to remove the noises by using the different techniques like binning. Okay, binning by bins of bin means, and binning by means of bin boundaries. Okay, in this way we are going to nullify the noise. And regression, guys. Okay, what is meant by regression means we will have the linear regression and multidimensional regression. Okay, linear regression means we will going to find out a relationship between the two variables with the form of equation. For suppose we will have the two variables means okay, how we are going to find out the relation means with the help of one line equation. Okay, okay, with the help of that line equation, if I know one point, that is one data attribute. Okay, if I substitute that attribute value in the line, I will get the another attribute value. Okay, and moreover that, guys, with the help of this regression we are going to eliminate the errors also. Okay, the points that is outside of this line we call them as a erroneous data. And the next one is clustering, guys. Okay, clustering means what? Okay, here with the help of the clusters also we are going to eliminate the errors. Okay, how? The any point, any data object that is outside of these all the clusters, we can say that those points we call them as a erroneous data, guys. We call them those points as a erroneous data. Okay, and the next one is attribute constructions. Okay, attribute construction. Okay, what we are going to do here is we are going to construct a new attributes. Okay, by adding a set of attributes, guys. Okay, what we are going to do here is, guys, we are going to make a new attributes from the already existing attributes. Okay, that will be helpful for the data mining process. Okay, for suppose data mining need only one attributes. Okay, in place of that one, what we are going to do is we are going to combine the two or three attribute and we are going to make that one. For example, okay, annual report. Okay, but I am having in the data mining previous step, okay, I am having the only monthly database. What I am going to do is I am going to aggregate those values. I'm going to aggregate the monthly 12 months sum. I'm going to get the annual year report, right? Okay, I have only the monthly report. How can I get the year wise report? Means I'm going to combine all the months from January to December. I'm going to combine, I will get the annual report. Likewise, I'm going to construct the new attributes from the already existing attribute set of attributes, guys. Okay, the same thing also followed in the aggregation also. Okay, here what we are going to do is we are going to summary of aggregation of operation applied on data, guys. The same. Okay, here a daily report I am having it, but I need the monthly report or yearly report. How can I do that one, guys? Okay, by combining the 30 days. By combining the monthly 30 days, I am going to get the monthly report. How can I get the annual report from the monthly report? Means if I combine the all the months reports, I will get the yearly report. I will get the yearly report. In this way we are going to get the an aggregation, guys. In this way we're going to get the aggregation. If I'm having the only day-wise data, from that one we can get the monthly data. Okay, from that one we are going to get the annual data also. Okay, guys, sorry, power loss అయింది. Hello guys, can you able to see the screen? Let us resume the session, guys. Okay, the next one is aggregation operation, guys. For suppose I have the only the day wise information, but okay, for the data mining algorithms it needs, for suppose monthly, means how we are going to compute means if you combine the 30 days of data, okay, we are going to get the monthly data. In this way we are going to aggregate the different attributes to get the required results, guys. The next one is normalization, guys. Okay, normalization, this is also used in the data cleaning. We have seen previously also. Okay, normalization, okay, in the data cleaning. Okay, the same thing also we can use it in the data transformation, guys. Okay, in the normalization what we are going to do is we are going to we are going to scale the attributes, guys. We are going to scale the attributes. For suppose for suppose the rankings, those are from 1 to 100. For suppose I want to scale it from another range. For suppose I'm going to scale it from 0 to 1. Okay, at the time what is the technique we have to use is we have to use the normalization techniques, guys. Okay, what is the importance of the normalization, guys? Okay, we can go for the smaller range representation of the different attributes, smaller range representation for the attributes. Okay, for suppose we can represent all the attribute numerical values to 0. 0.0 to 1.0, or we can go we are going to represent the attribute values to, okay, 1.0 to 2.0. Okay, whatever the range you want, you can represent those attribute set values with the help of normalization, guys. Okay, this is the smaller representation, guys. Okay, in place of the larger representation, if you want to go for the smaller representation, the better answer is normalization. With that help we are going to reduce the range of those attribute values. Okay, or suppose we can range it from 0.0 to 1.0. Okay, and the other one is discretization, guys. Okay, okay, here we are, what we are going to represent is in place of the numerical attribute values we are going to represent it with the interval labels. Okay, we are going to represent with the labels, guys. Interval of labels. For suppose, okay, 0 to 10 and 11 to 20. Likewise we are going to represent the attribute numerical attribute values in the form of intervals, guys. Otherwise we can use the conceptual labels in place of the numerical attribute interval values, like youth. Okay, that is like from 18 years to 35 years, so like 40 years, that will comes under. Okay, sorry, youth means that is smaller range. Adult means 18 to 35. 35 to above is a senior range. Okay, in place of the age, okay, we can represent it with the interval of labels, like this is a conceptual label, guys. Okay, interval of labels means some numbers 1 to 20, 20 to 30, 30 to 30. Those are interval of labels. In place of that one also, we can use the conceptual labels like youth, senior, adults, like that. Okay. This is also one of the data transfer. We are going to transform one data from one form to the another form. Okay. And the next one is concept hierarchy generation for nominal data. Okay. Here what we are going to represent is we are going to okay, we are going to represent higher level of concepts in place of lower level of concepts, guys. Like the street is a lower level of concept. Okay, in place of that one, I am going to represent it with a high level of concepts like city and country, like that, guys. Okay, smaller street, that is a smaller lower level of concept. Okay, that's going to, I'm going to represent with a higher level of concept by using city and country, like that, guys. Okay. Let us resume, guys. Okay, the concept hierarchy generation for nominal data. Here what we are going to do is we are going to represent the higher level of concepts in place of lower level of concepts, like the street is a lower level concept. In place of that one, I am going to represent it with the higher level, like city and the country. Okay, like RRPet, that is a street. In place of that one, we can represent it with a city, that is Eluru, or we can represent it with a country name, that is India. That is one type of data transformation, guys. Okay, here example, age, youth. Okay, that is a labeling, guys. Okay, where we have used that one, labeling. With this one, right, discretization. Here is the example for the discretization. Youth means 20 to 39, middle age means 40 to 59, senior means above 60 years. That we call them as a data discretization example, guys. Okay. If you have any doubts related to any concept, you can ask anytime, guys. Okay. One more thing, guys, the assignment questions is already posted in the Edmodo, right? Okay, you have to complete that one in time. That is, I think 28th is the last date for that one. That is posted 2 weeks back. And one more thing, first unit and second units PPTs as well as documents already shared in the Edmodo, guys. We start preparing for that one, guys. We have the exams in the first week of the May, right? Okay, first unit, second unit PPTs as well as documents already shared in the Edmodo. And for the related to the classroom, okay, all the YouTube videos are posted in the YouTube channel, that is CRRIT 3Y. Okay, you can search it there in the YouTube, guys. Okay, CRRIT 3Y, CRRIT 3Y third year. Okay, you can search it in the YouTube, guys. All the videos are already shared in the YouTube, guys. Okay, start preparing, guys. And the next one is next subtopic related to the data transformation is data transformation by normalization. Data transformation by normalization. Okay. Normally, guys, the measurement units affect the data analysis. For suppose in our India we use the kilograms. Okay, in UK they use pounds, and USA they use another. Okay, likewise for like height, we uses some uses in the units in the meter, some uses in the inches. Obviously, data collected from that one also will be in a different unit. For suppose India, if we collect the weight, means that will be in the kilograms. If in the UK, the weight will be in the pounds, guys. Okay, that will leads to very difficult results, guys. If you went for the data analysis, means if you combine this one, means without any transformation, we will get the difficult results. Okay, that is why, okay, they will have the different methods like data normalization. Okay, mainly we were going to discuss about the min max normalization and z scale normalization and decimal scaling. Okay, these three are the normalization methods we are going to discuss here, guys. What are the methods for the data normalization? Min max normalization we are going to discuss. Okay, and the next one is z-score normalization, and the next one is normalization by decimal scaling. For this, for performing this one, guys, we are going to take one attribute. The attribute name is a, that is a numerical attributes. How many values are there in the numerical attributes means n observation values are there. Okay, from v1 to vn. Okay, vn is the last attribute value. Okay, attribute value, and the v1 is the first value of that attribute, guys. All these attributes are numerical attributes. Okay, v1 is a numerical attribute, v2 is a numerical, and vn also numerical attributes, guys. What is the name of that attribute, guys? A is the name of the attributes. Okay, how many observation, how many values are there, how many records are there for that? A means n observation values there. Okay, what is the first value? V1. What is the last value? Vn, guys. Okay, let us see the first one, guys. Min max normalization. Okay, this is also one of the normalization technique, guys. With the help of this one normalization, we are going to change the range according to your scenario, guys. Okay, according to your scenario, we can range that values of attribute values. For suppose salary is there from 10,000 to 1,20,000. I want to scale that one. Okay, from 0 to 1. Okay, with the help of this min max normalization technique, I'm going to convert. Normally, guys, normally the range will be from 0 to 1, guys. Okay, the range will be from 0 to 1. Okay, whatever the range, you can go for it, but normally, guys, the range is from 0 to 1. Okay, here, for suppose for performing this min max normalization. Okay, min a means the minimum value of a, that is old values. Okay, maximum a means that is the old value, maximum value. Okay, I'm going to convert that one to the new other values, that is new max is the new maximum value. Okay, new min is the new minimum value, guys. Understand, guys? Okay, va is the value. Previously told you, v1 to vn are the attribute values. Okay, here the maximum value is represented with the max a, and min value is represented with the minimum a. Okay, okay, the my I want to convert those values to the another values, those ranges from, that is the new min and new max. The values, the after the conversion, the values are from new minimum to new maximum. Okay, here I am going to scaling to the new different range, guys. The older value, maximum value is max a, older value, minimum value is minimum a. Okay, after the conversion, the maximum value of new value is new max. Okay, what is the minimum value of new range is new min, guys. By using, okay, we know all the values here. New value of new max, we know. New min, no, we know. Minimum value of old value, old range is no. Maximum value of old range is no, and vi value also we know it. Okay, this is the formula, guys. Write down this formula, all of you. Okay, by using this formula, I'm going to do one problem, guys. Okay, write down this formula, all of you. Okay, in the min max normalization, this is the formula. By using this one, we are going to get the new, okay, the scaled range value of attribute with the help of this vi bar. Okay, vi is the old value. Okay, this is the minimum of old value, and this is the maximum of old value. Okay, these are the values I want to convert, guys. From maximum to minimum, these values I want to convert this range. Okay, for that, the new max is this one, and the new min is this one. Okay, this is the formula. All of you wrote it down, guys. Okay, in the paper and the notes. Okay, by using this one, I'm going to convert this to another range, that is new max to new minimum. Right, let us solve the one problem related to this one, guys. Then you will be able to easily understand, guys, what is the importance of this normalization, guys. Okay, we are going to scale to different range. For suppose the salaries are there from 10,000 to 40,000, I want to convert that one to 0.0 to 1.0. Okay, for that, different techniques are there. One is new min and new max. Okay, okay, after the conversion, what is the new max value by 1? What is the new minimum value? 0. Why? Because I am going to convert this range to 0 to 1. Likewise, we have to do perform it. Here, minimum value no, we know, maximum value no, new max value no, new minimum value no, and vi value no. Okay, let us see one problem related to that one. You can easily understand this, guys. Okay, let us read this one, guys. Okay, Here the new max and new minimum min max normalization, what is the problem they have given is maximum and minimum values of attributes of income is 12,000 and 98,000. Okay, what is the minimum value of income is 12,000, what is the maximum value of income is 98,000. Okay, they want to map it to 0.0 to 1.0. What is the new max value here? 1. What is the new min value here? 0.0, guys. Okay, for this one, for the particular value, that is 73,600. Okay, we want to convert that one to new range and take 0.0 to 1.0. This value will be here. Okay, in that, for that we have to calculate, guys. Okay, what is the formula here, guys? VI. What is the VI here? What is the value we are going to convert? That is 73,600 first, minus. Okay, what is the minimum value of old one? Okay, here is the old one minimum value, that is 12,000. Okay, 73,600 minus 12,000. Okay, coming to the denominator, that is max a minus min a. అంటే old కి సంబంధించిన maximum value and minimum value. What is the old కి సంబంధించిన maximum value? That is 98,000. What is the related to the minimum value related to the older value? That is 12,000. Okay, till now we have calculated this part. Okay, what is the this part here? New max. What is the new value maximum value? That is 1. Okay, and the next new value minimum value is, that is 0, guys. Okay, till now this part is over. Okay, what is the new minimum value? What is the new minimum value is, that is 0.0. Sum is 0. This is the transformed value of 73,600, guys. And moreover that, guys, 73,600 will be in between the 0.0 to 1.0. Am I right or wrong? 0.7, that is value in between the 0.0 to 1.0. In this way we are going to convert the all the attribute values to the newer range with the help of min max, guys. Okay, write it down, guys. Anyone having any doubt, ask me, guys. Okay, first you have to write it down this formula. After that you have to write it down this calculation, then you can easily understand, guys. Okay, first write down this formula. Okay, next write down this formula, guys. Okay, guys. Any doubts related to this one? Okay. The next one is second normalization techniques is Z score normalization, guys. Okay. Here we are going to use mean of that attribute and we are going to use standard deviation. With the help of this one, I am going to convert to the another range, guys. Okay. Here in this normalization, we are going to use the mean of that attribute and we are going to use the standard deviation of that attribute. Here A bar is the attribute mean. Okay. This is the standard deviation, guys. We have to use this one for the newer values. Okay. Write down this formula, guys, for the Z score normalization. Okay, if the formula is, if we know, then we can easily convert that attribute to new range, guys. Okay, the attribute range we are going to easily convert to the new range with the help of this formula. Write down this formula, that is Z score normalization. For calculating the new range of that particular attribute value, okay, we have to use the mean as well as the standard deviation of the A attribute, guys. Okay. Okay, let us see one example related to this one, then easily we can understand that one, guys. Okay, this is the example, guys. Okay, for the Z score normalization, the problem here is they have given the mean as well as the standard deviation. What is the mean of that attribute, guys? That is 54,000. What is the standard deviation of that attribute? That is 16,000. Okay, okay, for 17,600, okay, they want the new value. Okay, what is the formula here, guys? Let us see the formula. Okay, that is VA. What is the old value here? This is 73,600. We are going to convert to the new value. Okay, the old value we have to write it here. The formula is VA means the old value. Okay, the next one is mean. What is the mean value here is, that is 54,000 is the mean minus 54,000. Okay, the next one is denomination is standard deviation of A. What is the standard deviation here is 16,000. By 16,000 we will get the new value, guys. In this way we are going to convert the one value to the new range value, that is in the Z score normalization. Z score normalization, we need the mean of that attribute and we need the standard deviation. If we mean and standard deviation, we know we can convert that one attribute to another range, guys. That is with this help of the formula, that is new value minus the old value minus mean by standard deviation. Okay, we get the value is 1.225, guys. Right? Any doubt? Okay. The next one is normalization by decimal scaling. What is the third method, guys? Normalization by decimal scaling. In this method also we are going to convert the one range to another range, guys. One range of attribute values to another range of attribute values. Okay, right? How we are going to convert here in this decimal scaling is, guys, we are going to divide that value with by 10 power value. How we are going to 10 power value means, that is the value of maximum absolute value of A. Okay, that we are going to divide. This is the old value, guys, and V bar I is the new value. Okay, how we are going to get the new value from the old value is, we are going to divide with the 10 power value. How we are going to get the 10 power value means, that is the maximum absolute value of A. For suppose the values are between for suppose 98 is the least value, highest value is 979 for suppose, minus 977 for suppose, that is the maximum value. Okay, how we are going to convert that to 10 power means, the nearest absolute value of 10 power, that is 977, the nearest absolute value of 10 power is 1000. We are going to divide that value with a 10 power, that is 1000 value. Okay, let us see one example, guys. Okay, first of all understand this one, simple one, nothing is there, guys, if you see the example. Okay, understand this point. Here normalization means we are going to convert the attribute value to some other range. Okay, here how we are going to convert means, we are going to divide that one with the 10 power j value. Okay, how we are going to get the 10 power j means, that will depends upon the maximum absolute value of A. Maximum absolute value of A, that is for suppose maximum absolute value is 979 suppose, for suppose. Okay, what is the nearest value of 10 power value is, that is 1000, guys. Okay, we are going to divide that one with a 1000. Okay, we will get the new modified value for that particular attribute value, right? This is the formula for that one. Let us see one example, guys, then you can easily understand that one. Okay, here is the example, guys. Okay, in the decimal scaling we have to perform the scaling here in the decimal scaling normalization method. Okay, recorded values are from, okay, minus 986 to 917. Here what is the maximum absolute value is 986. Absolute value means 986. Okay, nearer by 10 power value, what is the nearer by 10 power value? That is 1000. Okay, means we are going to divide that number with 10 power 3. 10 power 3. What is, for suppose 917, I am going to normalize. Okay, 917 by 1000 means 0.917. This is the converted value, guys. In this way we are going to perform decimal scaling in the normalization. Decimal scaling in the normalization. Okay, guys. Anyone having any doubt related to this one here? Simple one, guys. Normalization means we are going to convert the normal values range to another range. Okay, for suppose the values of attributes are from 1 to 1000 are there. Okay, I want to convert those all values to another range, that is 0 to 1. Okay, how can we convert? With the help of normalization method. What is the first method? Min max normalization, one formula is there. The next one is z score normalization, one formula is there. And the next one is decimal scaling. Decimal scaling is simple one, guys. Here the maximum value we will take, nearest 10 power value we have to divide that one, we will get the value of the converted one, guys. We will get the value of converted one. Okay, in this way we are going to perform the normalization by decision scale. Okay, next one is data discretization. This is the last topic in the second unit. Okay, we are going to we are going to continue in the next session, guys. Okay, in the afternoon 2 to 2:50 I'm going to explain about the VICA, that is lab cycle 1 and lab cycle 2 program. Those are related to pre-processing. I am going to explain again for one of your friends asked me to explain that one, guys. Okay, that is why I'm explaining this lab cycle 1 and lab cycle 2 in the next class, that is 2 to 2:50 today. Okay, thank you, guys.